Hi, good morning, everyone.
Good morning, sir.
Good
Uh,
morning.
Good morning, sir.
yeah, thanks.
Morning, sir.
Yeah, thanks. So we'll wait few minutes so that more student can join. After that, we'll start.
Okay, sir.
Good morning, sir.
Yeah, good morning. Hi, once again. Good morning, everyone.
Good morning, sir.
Yeah. So today's outline of the session is first we will discuss about drawback of file systems, then we will discuss about levels of abstraction, then we will discuss about query optimization. So let me start with drawback of file system. Then we will take our doubt. So yeah, my screen is visible.
Yes, sir.
So yeah. So I think all you know what is file system. A computer system always has file system, right? So if you are working on Windows, you get see through Windows Explorer, or if you working on Linux, you get see through hierarchy of directory is a view of the file system. So you can give any document in electronic and bundle them into a folder, right? And you have various types of files. Now we'll discuss about what are the drawbacks and what are the problems of file systems to store the data. First problem is data redundancy. Data redundancy means same data is repeated at multiple places. Okay, so let me see an example. If you see that computer science this data and this data and this data is repeated, right? Computer science 75,000, computer science 65 5,000, and computer science is suppose sorry. So this is the okay.
Excuse me, sir.
Yeah.
So sorry to interrupt in between. So I'm downloading Postgres SQL and I'm
Uh,
facing problem at some point. Here it is written, please select the application you would like to install, and in the categories I have add-ons, tools and utilities, database drivers, database server, registration required in trial products, replication solutions, spatial extensions, web development. So what should I select from these?
Just
uh,
a sec.
Hello.
Yes, sir.
Yeah, yes, Fishti. I think you already installed PostgreSQL. So it's showing option about the stack builder. So no need to install the stack builder. Just you can simply skip that part.
Okay.
You
Thank
can
you, sir.
cancel it. Yeah.
Thank you, sir.
No need to install the stack builder. Okay. Yeah.
Okay, sir.
hmm
okay.
And please, everyone, if you have any doubt, you can ask after the once the instructor complete this topic. Okay. Yeah.
Yes.
Thank you.
Okay. So let me data redundancy. Let me see through an example. So suppose you have the on university lesson an instructor, right? So suppose instructor ID and the name, then department name, then department building, building name, and then budget, right? Mm. Suppose instructor ID is one, name A, department name is computer science, and department building is suppose X, and budget is like 50,000. And another instructor ID is 2, name is B, department is music, department building is like Y, and the budget is 60,000.
So what does budget indicate?
Budget is department budget.
Okay. The
And
building
the,
budget.
yeah, department corresponding
Yeah.
department name is budget. Right? And the suppose another instructor ID is 3, name suppose C, and department name is computer science, and department building is X, right? And budget is 50,000. So if you see through this data is repeated, right? Everyone got it? This data, whenever computer science department come, this data will be repeated. Department name and building and budget.
Yes, sir.
So this is called redundancy. So what are the problem with redundancy? It leads to inconsistency. Means consistency in the sense of, suppose department budget is changed or department building is changed. If you update this, quite possible you forget to update another, right? So it become inconsistent. So everyone got is what is data redundancy and inconsistency.
Yes, sir. Yes, sir.
Okay, so we'll go through the next point. Okay, then next point is difficulty in accessing data. So suppose if you have if you have data in CSV file, so the only way you can open it either as a notepad or just like a you can open in the Excel file, a kind of spreadsheet application, and traverse them into a table as a table. You cannot do anything in an automated fashion, right? So uh, uh, suppose if you have various types of file, if you have to write or you have to write program for each file for each new task, so that difficulty in accessing data. So everyone got it, difficulty in accessing data.
Yes, sir. Yes. Sir, if we want to open a new file, then also we have to write a program and then.
No, suppose there are maybe sometimes you have to write a program. So
But in what scenarios, sir?
suppose if you are,
In what scenarios?
it become many scenario, right? Suppose if you want to new tasks or something, new things, so you may have to write new program. So that is difficult to accessing that, right?
So
Then
each time we have to write a program.
it may vary. Suppose suppose there is a, I'm giving an example. Suppose there is a address, so instructor. So it consists of ID, name, and department name. So suppose we want only the name of instructor, music department, or something else. So you write a program for fetching the names of instructor in music department. Suppose then another requirement comes is those are music department and name starting with like I, or suppose there is address or pin code. So another requirement music and pin code is 600 something. Then you have to write a new program, right? That is the accessing of that. Okay. Now second is third one is data isolation. So because data are scattered in various files and files may be different formats, so writing new application program to retrieve the appropriate data is difficult. So then because of multiple files and format, data isolation. Then there is big problem, integrity problem. Suppose you want to add new constants or new integrity, so it is very difficult to add integrity in file system. Let's give an example. Suppose there is a bank account. So account for withdraw money, account balance must be 0, right? So somehow you add a constant account balance will be greater than 0. But if you want to add some more constants, then it's very difficult to add a new constant in file formats. So everyone got it, integrity problem. Don't worry, you will learn about integrity problem in detail week 3. So that is separate module in week 3 integrity. You will learn about check constants and various things. So everyone got it, integrity problem.
No, sir. Just repeat for the what do you exactly mean by integrity problem in file system?
No, not it file system. Suppose integrity problem generally, like if you want to add some constant, so that is very difficulty in to add new constant. That is very difficulty in file system. So we are learning what are the drawbacks of file system.
Also, sir, as explained in the lecture, also this integrity.
Yeah.
So same example they have given, the count balance should be greater than 0. So we have understood this part.
Okay. Thanks. Now atomicity. So atomicity mean I do intertext or I do not do at all, right? So let's give me an example. Suppose there are two account A and account B. Suppose we are transferring money from account A to B, right? So transferring 100 amount of money. So whatever it debited from account A, but if not credited, suppose it is debited account A and database maybe maybe some shutdowns or maybe corrupted files, so it leads to inconsistent, right? So because it's debited from account A but not credited to account B, so it may leads to inconsistent, so very difficult to maintain, right? So there is maybe problems there are various problems to atomicity of address. Or while in DBMS we have a rollback option, we can roll back, but in file system we have to do manually, right? So it becomes inconsistency state. Right, everyone got it? Atomicity, what do you mean by atomicity?
Yes, sir.
Okay, then there is a concurrent access.
Sir,
right?
repeat it once again, sir. Atomicity.
Yeah,
Okay,
please. Atomicity mean I do intertext or I do
Nothing.
not at all, right? So suppose there are two accounts. I previously have given example A or B and transferring money from A to B. So suppose it's debited to account A, right? But not credited to account B, right? So it leads to inconsistency, right? It debited but not credited to account B. Somehow this system may be corrupted after the debit of account A. System may be corrupted, right? So not credited to account B. So it means no, maybe inconsistency states. So that's so that's the atomicity.
Okay, halfly executed task.
Yeah, happily. So you will learn about week 10 what is atomicity.
I think it's like a payment failed kind of thing, sir. You mean to say payment failed?
Yeah, payment fail. So in database there is we have option of rollback, but in flat file in file system we have to do manually, right? So it be very difficult to become to maintain consistency. So that's it. So
But
you
sir,
learn about weekend, what is atomicity, what
sir,
is yeah.
one question here for this atomicity only, like how the file system is used to do the transactions, sir. Like
So
how
yeah,
it will, yeah, how it will be used actually. Database side is okay.
yeah.
You can write there will be some kind of update will be happening, but how the file system will be used actually for the transactions.
So yeah, we are seeing what are the drawbacks of file system. So yeah, we are using database in very efficient manner, efficient. So how we using, we have in professor we have 1.3 we have seen the how transaction happen, and also you have upload the GitHub on the code, you can see through how actually working. You have to open and you have to
Yes, Hari. This is the drawback of the file system. So we are, Subhendu is explaining. So this particular atomicity is the drawback. We cannot means take advantage of the atomicity in the file system, right?
Okay.
Okay. Is it clear?
Actually, I was confused between the file system and database, sir. Actually, that's the confusion I had. Like, so I asked question, okay, how the file system will be used for the database transactions. So, yeah, I'm clear about the atomicity, sir. No issue.
Okay.
But I was
Okay.
confused between the file system and the database. Still, I was confused actually from the since day one actually. So I'm not clear.
So you can think about the flat file. There is the flat file like the CSV, TSV, and your file, general file you have used in the window. That consists of the file system, right? Whatever you
Yes,
use in
correct.
the window, that is the file system, right?
Okay.
And in the DBMS, like DBMS, suppose software you are using, right? MySQL. So this DBMS system use that file system in such a manner so that you can store the data and retrieve the data efficiently. That is managed by the database management system. So
Okay.
not worry about that. That is managed by the software, right? How to use it.
Yes, I understood, sir. Yeah.
Yeah. Sure. Thank you.
So
Yes.
just add to this question. Actually, what I understood that Hari is asking, when we are storing the data in a file hierarchy, I can store data in the file hierarchy or I can store data in the database. So the question is, when I am storing data in file hierarchy system, how can I transact, means shifting one data to another point from the file system? That I believe he wants to know.
I think if you are directly use the file system, so that is the drawback of means you cannot use like you cannot take advantage of the atomicity. Suppose you are using for the transaction. Let's take example of the transaction, right? So you are using direct one CSV file, right? For that a CSV file, all know it's like the Excel sheet, comma separated value. Is it clear to everyone? So suppose you are directly using one CSV file to contains your data, keep your data, right? And suppose someone is using the DBMS, means database management system. So if you are using the CSV file, then you have to manually do everything, right? But if you are doing the database management system, then you have to, whatever Subhendu is talking about, the atomicity, that is taken care by the DBMS system. But if you are directly using the flat file, then you have to take care of that the atomicity, means manually, whatever.
Got it. That means in flat file or file system, I have to do every work manually.
Yeah.
So atomicity depends on me, how I ensure that the atomicity.
Yes. Suppose let me take an example of, suppose there is a X value in your database, right? X value, and this X has the 5 instances of that data in the database, right? Is it clear?
Yeah.
So suppose X has the 5 instances. So, and you have to update the X value. What happens in the DBMS? If you update where X equal to, means suppose if you, yeah, sure.
No, yeah, go ahead, sir.
Yeah. Suppose X previous value is X equal to 5 and you want to update the X value to 10. So if you write the simple query in the database, it got updated, right? No need to worry about that. But if you are doing that things in the file system, you have to done manually. You have to, suppose you have to search X value where X value equal to 5 and you have to manually do it, right?
You have to go
X
through
value
each
equal to
file.
5 and each and every 5 instance. What happens if you updates the X equal to, suppose 3 instance you updated, right? After that your power failure happens, right? So what happens, you updated only 3 value and 2 value remains as the previous value. So X value equal to 3 instance, X value equal to 10, and X value and 2 instances, X value equal to 5. It may be happened, right? So that is the case of, so what happens if our failure happens, then you have to roll back everything. Whatever changes you have to done, you have to undo the change, right? That is Subhendu. I think Subhendu is going to make this point. So what happens, you have to roll back to up to the whatever's the previous value, right? So that is the atomicity, but it's not happens in the flat file. So it, I think it is clear to everyone.
So if we do the rollback, then if we want to again do the changes, then we can do in the file system or in the database. I mean, once the power failure means if the power
in the database, it will be automatically taken care by the DBMS system. But in the file system, you have manually change and save it each and every instance.
Okay.
So, yeah.
So, okay, that's the issue.
Yeah.
Okay.
Yeah, Subhendu.
Yes. Thank you.
Okay, so everyone got it, atomicity. Now we'll discuss about concurrent access. So don't worry, in concurrent access, how we means how we do concurrence. We'll learn about week 10 in detail. So basically concurrent access increase the performance, and we can at the same times we can work, we can in the help of in DBMS, with the help of concurrent access, means we can do it, means we can there are transactions we can do in concurrently. So concurrent access is a big advantage in DBMS. So if you did not understand, don't worry, we will learn about concurrent access in detail, and you can understand that concurrent access increase the performance, or in flat file system or file system, it's very difficult to access concurrently. It may lead to inconsistency, right? So now we'll everyone got it, concurrent access? Hello, am I audible?
Yes, sir.
Okay.
Yes, sir, we got it.
Okay, now security problem, right? Okay, so in flat files, it's very difficult to give layers of security. So but in DBMS, there is a we'll learn about after that this topic, levels of abstraction, like view levels, logical levels, and physical level, right? But in flat file, it's very difficult to implement security problem, right? Suppose there is a instructor, right? Instructor not need to be see the information of other instructor salary, right? So it's very difficult to implement security problems in file system, but you can implement database management system easily. So there are levels of abstraction. So we'll learn about after this. So everyone got it? A drawback of file system. What are the drawbacks?
Yes, sir. Yes, sir. We have overview of the drawbacks of file system.
So, sir, in security systems, security type problem,
Yeah.
in the file system, we can't add more layers
Yeah.
to secure our file. Or
Yeah.
Okay.
But
But
in
in
DBM,
database, we can do this, right?
yeah, there are 3 levels of abstraction: view
Three
level,
level.
logical
Okay.
level.
Biological.
Yeah.
Okay.
Yes. So now we'll discuss about levels of abstraction. So Pradeep.
Yeah, thank you. Thank you, Spindu. Okay, let me share my screen. Okay. So now we discuss about the level of abstraction, right? So before discussion about the level of abstraction, I want to know about what do you know about this abstraction? What do you mean by this abstraction, right? Anyone would like to explain about abstraction part?
Abstraction, you can say some hurdles or difficulties to achieve, or I need to cross some barrier to achieve that.
Okay.
Abstraction is when you hide some part of your database. For example, let's say you have a database of a car and all the cars, but you give access to only one car to particular system.
Okay. Anyone else?
Abstraction is like the end user should never understands what fields and actual fields and fields are present in the table. For example, in a company, some person in the marketing will not have any access to anything related to finance. For example, in the same table, if the columns are present, and like that can be achieved by creating certain view or some queries and creating a kind of a table over there, and giving access to that user only to those particular columns which are related to the marketing. That's what I think.
Okay. Anyone else?
Abstraction brings access control to the database.
Okay. 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 I think that's it. Okay. Let me explain about the abstraction. So abstraction means you hide the background details. What happens in the background details, and only show the useful data to the user. That's it. Suppose I provide you a function, like suppose this is the add function, and you have to pass only 2 integer, then it will returns the sum of these two. So whatever's the algorithm use in between that, I hide that. So I provide you only this. So there is a one add function, and this you have to pass only 2 integer, and it will return the sum of the value, right? So that is the abstraction. Everyone got it? What is the abstraction? And another example, if I want to give you about the abstraction, means if a car, if you apply the brake, right, so then it will stop. You only know about that. If you apply the brake, then it will stop, right? But how the mechanism happen inside the car, that is not explained to you, right? That is hide to you.
Yeah. So the actual process which is not shown to us, or does not happen
Only
in
application. Only application is explained
visible
to
to
you.
us.
Yeah. Okay. Is abstraction is clear? So now we discuss about the data abstraction. So data abstraction means now we apply that things in the data. So only useful data is visible to you. Whatever useful to you, right? So in the computer system, what is the main utility of the database is so that user can efficiently store the data in the database and retrieve the data in the database. So that is the main use of that. So use of the store data efficiently and retrieve the data from the database efficiently, right? So for that, retrieve the data efficiently, you in the background you have performs means apply or implement many data structured or the indexes you apply in the background, right? In the low levels, physical levels, where you have stored the data, or the file where you store the file. So that is okay, let me. So for that you use some complex algorithm or the data structure in the means disk, hard disk, right? Okay. So for that purpose, so it got complicated. So for that we use the level of abstraction at the different level. So there are 3 level of abstraction. So first one is the physical level of abstraction.
Excuse me, sir.
Yes.
So can you explain what's the meaning of retrieving the data?
What is that?
Retrieve
Retrieve
data.
Retrieve.
Yes,
Retrieve means you want to extract the data from. You store the data in the your database. Sometimes you require that data also, right? So suppose you store the student data in the means the database. So now you want to see the data, right? So
Yes,
whatever's the data present in the student database, so you want to check or read the data. So that is the retrieval of the data.
Okay, sir. Thank you.
Okay.
So one question, if we want to see the data, why can't we go into the database and see the data? Why do we have to retrieve data every time and to view that data? I mean,
Means
that is my doubt. Means if you want to just view or view the data, we can use our database and we can go there and see stored where the data is stored. Yeah.
Okay. So let me give an example. Suppose this is your product and this is your order ID, right? So in the product, this is the product ID. It will store the all the product details right here, product ID and the product name. And this is the customer ID and the customer name, right? And this will store order store the customer ID and product ID, right? So if you directly go to the data, so you can see these table are individually. So you cannot get the original data. So just look at how can you interpret it. So this is the simple. So for that retrieval of the whatever's the required data, so you have to write the query according.
So if you just look at the customer ID and product ID, we can judge what
that
that
is
number is.
So you have to write some meaningful query. So that it will be meaningful. Okay.
That is where we use this.
Yeah.
Okay.
Sir, for me, retrieving and abstraction both looking same.
Retrieving? No. Abstraction. Okay, let me explain about the abstraction. So am I going to explain about that? So yeah. So there is the 3 level of abstraction. Okay, let me define first. Then if you have any confusion. So I write this point because store the data in the database, right? How to store that data in the physical levels, that may be complex to you. So in the database, okay, what happens in the database? So suppose you are using one DBMS system, right? So in here, suppose you want to create one product table, right? Product tables with the product ID and the product name, right? What happens? Okay, logical level. Let me first define this, then I will explain details about it. Okay, logical. Okay, in the physical level, what happens? How we store the data in the physical level or the disk. Physical level or in the disk, right? Disk means secondary storage. Is it clear how we storage the data in the physical level? That is handled by the physical level. And the logical level, what you are going to see means an application developer see this work on this logical levels. He defines the schema, right? Schema or table structured and whatever's the relation amongst these tables, right? That is defined in logical level. So basically all the application developer or the web developer working in this level, right? Logical levels, right? So it will explain about what data to store. And relationship among this data. Okay, and the view labels you provides only some useful data, right? Okay, useful data only some you define for the every user, you define some view to that, and hence the view level, so only the useful data is visible to them. Okay, now explain one by one terms with the real example, right? So suppose you have to create one, suppose you are using one database management system and you want to write create one product tables with the product ID, product name, and suppose this PID is integer type and this is a varchar type, right? So you create a tables using this statement, create table, right? Create tables product PID integer 1, suppose P name, right? So I define these tables using this command, so that I defined in the logical level, right? And how whatever's the data present in the product tables with this particular two attribute, how to store that data in the physical levels, that is handled by physical level abstraction, right? So I do not have to worry about how the data is stored in the physical levels, right? Right. And so whatever I define this table, so that happens in the logical levels. So in the logical level, what I said, explain about what data to store, right? I explain here. So that is the PID is stored. Is it visible to everyone, right? All.
Yes, sir. Your screen
Yeah.
is.
Okay. So what data to store? So that is PID I have to store and PNAME I want to store. So that explains about what data to store and what is the relationship amongst this data. So suppose I have to define this three relation, right? So then I have to mention also the relationship. So this ID of the customer tables, and this is the foreign key here. So whatever's value present here, it should be present here. So foreign key definition, and this is PID. So these are the relation. This way we defines the relation. So that we'll see on the upcoming week. That is the week 2. Okay. And the view levels. View levels there. Again, you can see the end user are suppose the clerk or the end user that are not probably is a computer trained user, right? So for that, we only provide suppose this product tables instead of the product table. Suppose this is the instructor table, right? And suppose this is the instructor ID, instructor name, and the instructor salary, right? Fair care.
Excuse me, sir.
Yeah.
So what are we writing in the brackets? Is this the length of the string?
Yes, yes.
But sir, name of the person may vary. So why are we writing it as a 20 or some fixed
That
value?
is the varchar. So you know difference about the varchar or the character. What is the difference between? Okay.
No, sir. We know character, but varchar we don't.
Varchar means this is the character. This is the static length, and this is the variable. Varchar is the variable character, right? So suppose you define this as the 10, not 10, 6, and this is also 6, right? So I said this is the static and this is the dynamic. What means? So suppose you write ABC and you write the ABC in the varchar and the character ABC, right? Here you can see the character is the I said static, means this will take also this 3 character also. So first we define 6 space, then we utilize only the 3 space amongst them. Remaining are got wasted, right? But in the what happens in the variable character? So it first define the 6 character, then only it takes whatever's the character used. How many space we are used, right? So this we cannot take like this one. So this is the fixed, but we only use the 3 space, right? Maximum it can takes the 6 character, 6 space, but here we use the 3 space, then it only takes the 3 space only, right? Unlike the character, it wasted this character, this space only.
Okay, sir.
So you mean the three spaces are wasted in the character, whereas in the variable character, it's not like that.
Yeah, only use this means. Okay.
Okay.
Okay. Is it clear? What happens? So now we are discussing about the view level. So here,
Can I ask a question?
yeah, sure.
Sir, like you have mentioned this product ID, order, and customer in the physical, logical, and the view level you explained. So
Yeah.
would it be correct to assume that the schema gets created in the logical level?
Yes. And how that schema is stored in the physical level, that is happened in the physical levels. Physical, how to stored in the data, that is taken care in the physical levels. You do not know how your data is stored in the physical level, right? What data structure is used for the retrieval of the data efficiently. What indexes are used in the means disk, right? That is unaware about it. You all are unaware about it, right? That is the physical level, right?
Got it. Sir, here is the thing, like there's a logical level. I can understand about the logical level schema. And can you also, I mean, I don't know if it's the right time now, but explain about the physical level schema. I believe I came across this term while going through this.
So physical level schema means how the physical, whatever's the design you or the structure you used for the physical level schema, physical levels, that is known as the physical schema, right? So
Okay.
what they
So, like you're saying that the web developers and the programmers work at the logical level and they design the logical level schema. So, who takes care of the physical level schema? Like who designs or who is responsible for the physical level schema?
suppose you want to create university database, right? So for that we hire the database designer, right? So database designer based upon your query, right? So whatever's the query is frequently triggered or the fired in the database will be fired, right? So based upon he designs the file structure. So we will see the file organization, how your file should be organized into the physical levels. That will be designed by the database designer, right? So what a sequential file organization is required, or the heap file organization is required, that is designed by the physical levels. So that is hidden from the logical
And
levels.
so here is the last question. Like you said, you wrote here create table instructor, this instruction about creating a table of instructors. Or for instance, like if I want to create a product or an order or a customer, this is done at the logical level.
Yes.
And this is done by, say, a language like SQL.
Okay.
And
Yes.
this is the logical level schema, right? I'm just trying to relate with the logical
yes.
level. So at the physical level, is the same language or the same thing? I'm sorry, I don't know how to articulate this properly, but is the same thing going on? Like the same code, same thing is get, or is it something else again? Like there's a different version of SQL that is at work by dividing the physical level.
Yeah. So that is actually the abstraction. We do not aware about the how's the in the backend how happened this thing. So that is hide from us. So I also don't know about how the in the backend it is stored, right? So that is physical level abstraction. So you do not worry about the how physical levels is happen. So that is taken care by the DBMS.
So in this course, you will only be worrying, only be involved with the logical level things, right?
Yes. From week to 8, we will only see about this application part. Application parts means this logical levels and the view levels. And from 8 to 9, 9 to 12, we will see some part of the physical level design. So how data is stored in, what indexes are used, right? How the query processing happens.
But so that is also logical only, right? The query indexes everything. Whatever talking is logical only. It's not a physical thing.
No. So you create your own index, that is different. So what the file system is doing in the physical levels for the retrieve that data. So suppose you want to means we are also can create using the logical levels, index also can create. So based upon this physical level get also organized the data. Hello.
Excuse me, sir.
Yes.
So, sir, can we say that a physical level gives us the layout of the data? Suppose if we are filling any application form, then we have to fill in with our names, IDs, and all that details. Then that layout is a physical level thing. And when we are completed with the form and we have filled all the values related to our name, IDs, and everything, then it gives us relationship between what our name is, what our ID is. So that's a logical level thing. So can we relate it to this thing?
No. I think you got this part, how to create the instructor. So that is the logical levels, and how data is stored in the physical level. I think physical levels means disk, hard disk, right? Hard disk or the secondary storage.
Yes, sir.
Okay. So how the secondary storage, the file organization, how you keep the records in the your physical memory, right? That things is the physical levels, right? And the logical levels means whatever the interface you design creates the tables. So for Fiji admin, I just gave an example. So in the PG admins, the interface, right? Interface appeared to you. So that you defines the tables. So that is you are working on the logical level, right?
Okay.
So that is the logical levels. And
Okay.
suppose you create one application on the top of it. Suppose you create one application for the instructor, right? So in the instructor for clerk, right?
Yes.
For the clerk, you create one application. So the interface like, so it will show only the instructor ID and the instructor name, right?
Yes. Sir.
So it will retrieve the data from this logic means your database and only show the ID and the name means instructor names. So here you can see here only you display the instructor ID and instructor name, not data type. What is the data type of the instructor ID? What is the instructor name? Instructor names, data types, how much length of that. So only show you showing the useful information to the user. So that is the you design for the end user. So this thing is called the view. So view labels. So hides the details of the logical labels. You hide the details of the logical labels and only showing the useful data to the end user. So that is view labels.
So, sir,
right?
in view level, we can see the physical level data structure, right? The logical level is hidden to us.
No. In the view labels, we cannot see also the logical levels data structured also.
Physical also not?
Excuse me, sir.
Not. We are not
No.
seeing any physical levels. You cannot, you can check also your Fiji admin. It is not visible to you.
See, like view is like that. Suppose you want to see your results, okay? Results, okay? When you click on your ID, when you enter your ID, right? So you see your marks over there, your name, your ID, and your details, right? Whatever marks you have scored in the different papers. So that presentation, that output actually, that is the output, okay? That you see. So that is a view designed for you. So their queries will be written behind. That is a logical schema, okay? In logic schema, they will be written a query. So whenever you enter your ID, they will fetch the details and will show in the view. So the view is nothing but the result you see on the screen, right? Your result. That is a view thing.
Yeah,
You take
yeah,
it.
that is what I'm saying. Okay.
Excuse me, sir.
Yeah.
So, what I understand from this is like if we store a data of 100 rows and 100 columns in the hard disk, then it will be stored in physical level. And from that data, if we want to create some tables, like 4 tables we have created of 5 rows and 5 columns. So that schema of those tables will be stored in logical level. and from those tables, like from first table we took one column, and from second table we took two columns, and display its structure, like whatever data it have, then it will be shown in view level. Am I correct, sir?
So whatever you explained, that is the you define some abstraction, how abstraction thing happens, but you are not completely correct, so I can say. So you can understand in this way what is abstraction also, but not the proper way to define the what is physical level. Okay, let me take one real life example. You can relate that thing also. So take this thing. Okay, just give me an example of that thing, so you can relate.
So can you show it in next page? Actually, it's this pages.
Okay, I think this is a screenshot.
Okay, awesome. Okay.
Okay, suppose let's take IITM want to create one university database, right? Is it correct? University database has following table, right? So what are the tables can you define? One is the student table, faculty table,
Department.
right? Department. Okay, give this for this. So for that, suppose you have yes.
Sorry.
Yeah. So for that, suppose designer. So you give these things into the database designer. So database designer do analysis based upon the user previous, suppose want to consult with your professor, students. So in this way, he designed what are the attribute required for the student. Suppose whatever the important information about the student, right? So that is the student ID, right? Student name and department, you can say course enrolled in, right? So these are designed by the database designer, right? And faculty names, the faculty ID, faculty name, right? And the faculty salary, these are the attributes, right? Okay, department ID, department name, right? So these are the means table of the university database, right? So how these things stored in the physical means we defines this data structured and relation amongst whatever's the relation. So suppose the course is one relation, course is established for the established relation, right? So that is the SID, student ID, and the faculty ID and the course ID, suppose. So in this way we build the relation, or create relation amongst them, right? So this is relation one. So how these things stored in the disk, so that is taken care by the physical levels. Whatever the file organization is need, what data structured is required for that, how to index this data in the physical memory, right? Or the secondary storage. So that things, the whole thing is come under the physical levels. So storing part, you can say simply say the storing part is come to in the physical levels, right? Is it clear to everyone?
Yes, sir.
Yes, sir.
Thank you, sir.
Yes, sir.
Okay. Okay. In the logical levels, you define each table define using some query statements or the SQL query. Define this. You have to define since the logical levels, right? Whatever the relation, everything like the create statement, create student, SID, integer, everything. That whole thing come into the logical levels and the relationship, whatever's the defined relationship. In the view things, suppose you create a student view, whatever you are logging into the IITM site, and you have the login ID, right? And so you have the authority to see only the content of the means only see the contents of the DBMS, right? So that is you provided to a view, right? Not whole the database. You cannot see the faculty details, cannot see the department details, right? You only can see your own course enrollment and whatever you are allowed to do. So that is you provides for you a different view student, for instructor a different view, for admin it is a different view, right? So in the view, the data type or the data length and so whatever's relation, how many tables are present in the database, that is not visible to the view level, right? So in this way, we applies the uh, logical level of abstraction here. I hope it is a little bit clear. You
Yes,
got the
sir.
idea, but this
Yes.
three level. Yes. So, okay. Okay, just is it visible? Right. So now if we want to draw the whole thing, so you can say, so this is the lowest level. So that is the physical level. Right. On the top of the physical levels, we defines the logical level. And on the top of the logical levels, we defines the view level. Like user one, user two, user three. Like, so same logical for the same database, we can create multiple view for the multiple user also. So here concept is that the whole so we can define all these things, means physical levels and the logical levels and the view levels, so independently, so that it cannot affect one another layer. So means if we want to change anything, want to change in the logical level, it should not affect the view level, right? And whatever changes we have to do in the logical level, it should not affect the upper level. Upper level means logical levels and the view level also. Is it clear? And that thing is known as the data independence, right? Data independence means we want to independence each level so that it should not affect other levels also. So between the logical physical levels and the logical levels, there exists the physical data independence. So as I earlier mentioned that for the tables, if you define something in the logical levels, for suppose let's give an example for your instructor tables. You first use the one sorting algorithm, right? Selection sort for the indexes purpose, like selection sort. But in the later stage, you can see it is not efficient, so that we want to change that algorithm, right? So whatever you want to change in the physical level, uh, in the physical levels, that should not affect the logical levels. So that is the concept of the physical data independence. Whatever changes in the indexes or the data structured you want to change in the physical levels, that should not affect, ideally should not affect the logical level, right? So that things is physical data independence. So you got it, what is physical data independence, right? So can anyone explain?
Yeah, sir. It's like we have taken some data, like integer character like that, and we manipulated in logical level. If we change it something in physical level, it should not affect our logical level.
Yes. So yes, that is.
We can say that like in object oriented programming, we define a class and we can change the code of a class, but the use of that class making some object would not change, would not affect actually.
Yeah. So that concept is happening in the logical to physical levels. So you can think like that concept in the data independence, but the thing is only need to take care about the whatever changes in the physical level, that should not affect the logical level, and whatever changes in the logical levels, that should not affect the view level. So that is known as the logical data independence.
Okay. I can understand.
Okay, let me give same example, instructor table. So instructor table have instructor ID, instructor name, instructor salary, right? And the view level, this is happened in the logical level, right? And the view level, this part is for the view levels. Suppose you clerk, so user one, suppose you can take as the clerk. So you provides the clerk a view that is only the instructor ID and the instructor name, right? This is only provide view to the clerk, right? So that, so suppose in the later stage you want to changes here, you want to add another attribute that is address, right? In the logical level, but you can see in the clerk it not affected, not got effect, right?
Yeah. Yes, sir.
Yeah, you can delete also address, not. So this is a concept. What happens if some student are asking like that, if we delete whole tables, then what happens? So that means the data is not exist, you cannot create also user also, that is different scenario, right? So okay, is this two concept, three concept, physical levels abstraction, logical level abstraction, and view level abstraction, and physical data independence and logical data independence is clear to everyone?
Excuse me, sir.
Yes.
So can you explain this physical data independence using this instructor example once again?
So yeah, so how this data is stored in the physical levels. So physical levels, whenever come the physical term, you can simply assume that things, it happens in the secondary storage, or you can see the disk. So somewhere you define that things into the DBMS, means data management system, using your PG admins or the Postgres SQL. So that things somewhere have to stored in the physically or in your computer, right?
Yes, sir.
So that things, or so for computer, you secondary storage is your disk. So that thing you have to store it into your hard disk, right? So how this thing is stored in the hard disk, so that is your physical level, right?
Yes.
And for the storing purpose, what data structure is used, right? So that thing, what data structure is used in the physical level, that is not visible to you. So that is the physical data abstraction. And if you in the later stage, if you want to change this data structure, first, let's say previously you are using array for storing this instructor data. But what happens in the later stage, you for the performance, better performance, you want to change this thing into the linked list, right? Maybe happen. So for that purpose, you want to change this data storing, this data structure linked list you want to use, right? So if you change anything in your the physical level, it should not affect the logical levels. It should not be visible to me that at the physical levels this has been changed, right?
Okay, okay, sir.
Okay. Is it clear? Same thing for the logical to view also.
Yes,
So
sir, it's
whatever,
clear now.
yeah. Okay. Is it clear to everyone? Hello.
Yes, sir. Yes, sir.
Yeah. So we can proceed to the query processing part. Yeah, Anjana, up to you.
Yeah, thank you, Pradeep. So, any of you have any doubt in query processing? Like I'll be discussing it, but if anybody of you have any doubts, please feel free to unmute yourself.
Good morning, ma'am.
Hello, good morning.
Yeah, ma'am, my doubt was what is parsing? Sir
Okay.
explains in the lecture.
Okay, so you have doubt, right? Okay, so let me begin. Okay, so a minute. So query processing basically involves three components, right? Parsing and translation, optimization, and evaluation. So in the beginning, we take an SQL query as an input. So if you can see here, an SQL query is taken as an input. So just for example, let us take one query, select name from say employee, where salary is less than 40,000. Okay, so consider that this particular SQL query is taken as an input. Now it will be moved on to the parser and translator. So now what the parser will basically do is the parser will check for any syntactical errors if available. So say for example, in this particular SQL query, if it was written something in such a way that select from employee where salary less than 40,000, then that would be a syntactical error, right? Because we are not selecting any attribute which we want to like get as an output, right? So in that case, the parser will take out the error, right? So what happens? So as I said, that the parser will check for any syntactical error. Okay. Now, what the translator will do is the translator will translate the query into a number of corresponding relational algebra expressions, which will be equivalent to this particular SQL query. Now, remember one thing, that a particular SQL query can have a number of equivalent relational algebra, which will give the same relational algebra expressions. It is just the difference would just be the cost that like gets involved basically. So now what the parser and translator has done is it has checked the entire query if there are any syntactical errors or not. If not, then the translator will translate this particular query into a relational algebra, into a number of relational algebra expressions. So say for example, it is converted into, okay, so we have to find out mean, then a condition is given that says salary is less than 40,000 and then the table. So about these relational algebras, please do not worry. We will be covering this in depth in week 4. So right now you can just go through it. Like you don't need to worry so much about it. We'll be discussing it in 3. Yeah. Yeah. Okay. So as I said that a particular SQL query can have a number of equivalent relational algebra expressions, right? So say for example, this is one relational algebra expression that is equivalent to this particular SQL query. Then another one we can take is select salary less than 40,000 and then project in and the table. Okay. So now what the translator will basically do is the translator will not generate this SQL, this relational algebra expression. In that matter, it will it will generate or it will form a query tree. Okay, it will not directly give this particular expression. It will generate an SQL and a query tree basically. So how a query tree looks like is, say for example, we will take the query tree of RA1. So it will look like whatever we need to select, project, then the condition, then the table name. Okay, again about the query tree, you do not need to worry about it because it will be covered in week 12 as how it is created, how it is done. So please do not worry about it. So say for example, this is the query tree. Now this will be passed on to the optimizer. Okay. So now remember that for a particular relational algebra, there could be a number of different algorithms. Okay. So say for example, in this table employee, there is this attribute named salary, right? So say for example, this the tuples or the records that are present there in salary are given in a sorted order, in an increasing or decreasing manner, right? Then what we can do is we can use a binary search tree, or we can also use linear search tree, or if say for example, we are using indices in our tree, then we can use indexing method also. So these are nothing but plans, okay? So now the optimizer will help in generating plans which are attached with different algorithms and will also calculate the cost that the cost of different relational algebra expressions. Now you might be thinking how the cost of the different algebra expressions along with the plans can be generated. So this will be done with the help of the statistics about the data. So the statistics about the data will consist of details which includes the relations, or you can say the tables, then the column names, the data types, or the data dictionary, which we also know as a metadata, that is data about data. So all those will be in the statistics about data. So the optimizer will use all the statistics of the data and it will calculate the cost of the plan. Okay. So after that, how the cost can be calculated is by knowing the disk access, the number of operations, and so on. Again, about optimizing, it will be discussed in brief in week 12. So right now you can just understand or get an overview, right? Okay. Then finally, the optimizer will fetch data from the statistics and then the plan, which is the most efficient one, will be selected. So that will be the execution plan, right? Then the execution plan will be taken as an input by the evaluation engine, which is a processor. Okay. So what it will do is it will execute the particular expression and then it will give the query output. It will process the execution plan that we have generated by the help of optimizer statistics about the data. So the evaluation engine is the processor which will execute it, and then it will return a query output. So that was it about query processing. Anybody, any doubt? If you have, please feel free.
Ma'am, can you explain what is the evaluation engine once again?
Okay, evaluation engine is basically a processor. So what it will do is it will take an input, okay, that will be an execution plan. By that I mean the relational algebra expression, which is the most efficient one, right? How we found out which is the most efficient one? By using optimizer, right? And the statistics about the data. So when we found out the plan, which is the most efficient one, so then we took that plan and then we passed it on to the evaluation engine, and the evaluation engine it processed that particular algebra expression and returned the query as an output.
So evaluation engine also uses the data, or it just evaluates whatever best execution plan is being passed on to it?
Yeah,
or it uses the data.
It will take the efficient, the most efficient plan.
Okay.
Ma'am, what's the use of this execution plan here after getting the most efficient method?
So the one that is the most efficient one is the execution plan, right? Like as I mentioned that it will the optimizer will help in generating plans, right? Which are attached with different algorithms. So the plan which is the most efficient one will be the final execution plan.
So optimizer would calculate for the most efficient plan and will
Exactly.
forward it to the execution plan. The most efficient one would be the execution plan.
Exactly, that's right. And then the execution plan will be forwarded to the evaluation.
Okay, okay, ma'am. Thank you.
Yeah.
Madam, in optimizer, how many type these programs will be there? Like how it will make into different architectures?
Okay. So about, as I mentioned, about the optimizer and all, you learn it in brief details in week 12. So you don't need to worry about it. Just right now, you can consider it as that the optimizer will find out the most effective plan. The other details will be clear to you when the week 12 is being taught. Is that okay?
Okay.
Yeah. Okay, some of you have raised your hands. Please unmute and.
I'm unable to understand as to where is this happening, query processing. Is this happening at the physical level, at the logical level? Like, how do I relate to this query processing part to what we have done so far, right?
I'm sorry, I was not able to understand. You mean that in which level of abstraction is this query processing done, right?
Yes, ma'am. Where is it happening? Like, is it done at the logical level? Is it done at the physical level? Is it done at the view level? Like, where is this happening? Is this happening in the SQL? I mean, can you just relate it to with the things that we have covered? Like,
hello. Yes. Yes, Anirvan. After you fire your PG admin, right? PG admin, you fire any query, right? Select a star from instructor. So what happens in the next process, that is explained by the Anjana. That is not, you do not want to do anything about it. So what is the background process? How the query is processed in the background. So that is explained.
yes, but which level is this happening? Like,
This is happening in the physical level. Is it clear, Anirban? Hello.
Yeah, it's kind of clear so far.
Yeah.
Okay, thank you, Pradeep, thank you, Anirban.
Yeah, I have one question.
Yeah.
Optimizer, when finalize the final execution plan, then that is fed to the evaluation engine. Now, in evaluation engine, only one execution plan, which is the best selected by optimizer, is fed. Is there any chance that evaluation engine is a decision box that I am seeing? That means, is there any chance that can be rejected?
rejected, like if how
No,
if it will be rejected, it will be yes, sir.
no. In optimizer, I find that there is a many input and one single output because of
Yeah,
something is going on. But how means I thought ki there may be 2-3 execution plan, evaluation engine, feeding the data and checking out of the best one is this part I don't know. Means why it is a decision box, means whether is there any chance that I have it is pass or not this plan.
Yeah, Anirban. If in the parser or the translator it got passed, then it will always pass through the execution plan. So suppose let's take an cost means minimum cost we only consider suppose 2, 3 or 5, right? 2, 3, 5, which is the minimum cost, that is 2, right? So if only one execution plan, you have only one execution plan, suppose that is 7, so 7 is always the minimum, right? If only one is present, so there is no question of any rejection. So
Which
that is the optimum.
Yeah,
That
like
is the
if any
optimum.
rejection is done, then it will be done in this step only.
Okay.
Okay. Is it clear, right? Okay.
Sorry, Pradeep sir, what you said in last thing, that if only 7 is the minimum, then
yes, if there is only one execution plan, right? And cost is 7, right?
Okay.
So which is the minimum?
7 itself.
7 itself. So that is there is no rejection of any plan, means execution plan. Yeah, that is.
Okay.
Okay. So anybody, any doubt in a query processing?
No, ma'am.
No.
Ma'am, I have a question, not regarding this, but regarding the query. The syntax of all these three, like your MS SQL or MySQL or Postgres SQL, the syntax is different or is somewhat similar?
Hello. Hi. Hello. Am I audible?
Yeah, yes, Subhendu, you are audible.
Okay. So yeah, maximum 90% things are similar, but some syntax may be different. Like MySQL, we are using limit clause, but in Postgres we are using limit offset. So some minor things may be different.
Okay. All right.
Hello, any questions from week 1?
Seven
Things about that installation of that SQL software and how it used to look at, we want to know, sir. Actually, we don't know how it is used and all. Just we installed and we don't know anything.
So you install, right? Hello?
Installation is done here.
So next you have to LIS database and FLIS database, and university you have to load the database. So let me let me see the one database. Okay. So let me.
Yes, sir. Please show that how it looks actually.
Okay. So these types of interface use. So my screen is visible. Hello?
Yes, sir.
Yes.
So so these types of interface will. So first, what we have to do? First create, then database, Then you have to give the database name, whatever you can give, like flash. I have give flash db. So already I have created flash db, so I give flash db1, right? Just you have to save the, yeah. Then you have to go, sorry, you have to do here flash db1. So you can see flash db1, right? You can see my cursor, right? So then right click, then you have to restore, right? You can see the restore. Then you have to click the restore. Then whatever the we have provided tar file, right? So you have to select the tar file. So actually let me see where desktop, sorry,
Sir, we extracted the files, but we only see the SQL file when we have when we want to export. Sorry,
so
when
there
we
are,
want to restore. We can't see the tar file.
yeah, there are tar file also also. Okay, so
Hello, Manan. Just on the right hand side, you can see the format. Just select all files option. Then you will be able to see the tar file.
All file, right?
Or all files, yeah.
Okay, sure.
then you have to select the tar file, right? flash db.tar. You have to select the tar file, then click the restore. So your registration job is completed, right? Then it restore or not, just write one query like flash db select start from where. Then click the, this is the run button, right? You have to click the, so you can see the
all the fields.
Yeah.
All the
So,
table.
yeah, all the, and you have to also the binary set the binary path. So we have given PDF instruction how to set the binary path in PDF.
That is.
So you can add this binary file. Okay. And in this way, you can restore the flash DB, LHDB, and the university database.
Okay.
So everyone clear
Excuse
with?
me, sir. What's
Yeah.
that thing about binary path you just said?
Yeah, you have to add the binary path. You can see the file. Then I think preference. And then binary path. Then you have to add the Postgres 10. You have to add the binary path. This program files. Then Postgres SQL. Then 10. Then bin. You have to add this binary file.
This path we have to copy from the desktop.
Yeah. Yeah, you have to add where the actually Postgres is installed. So you have to go to the C folder, then program file, then PostgreSQL, then 10, then bin, then copy the path and then paste. Just like.
We can copy it from here and paste it in the path.
Yeah, copy the from the C. Okay, I will show. See.
Where SQL is installed.
Postgres. Yeah. So yeah, my screen is visible.
Yes.
So you have to go to the this PC, then Windows C, then program files. Then you have to see the PostgreSQL. You can see the PostgreSQL, then 10, then bin, and you have to copy this path and you have to paste in the binary path. You have to paste in this whole folder, right? Okay. So in this way.
So what will be the location of the tar file, sir? Which folder? Like, I mean, it will be there in the.
Yeah, you can tar file. You can install desktop or anything. So you have to select when you select tar file, you have to select those locations, right? Let me. When you restore, you can see custom or file name. Then you have to choose the file name. If there is not in this location, you have to go to the like. If you are in the suppose if you are save in desktop, then dataset, right? You have to go to the dataset. Then if you want to restore the flash, right? Go to then click the double click of flash. Then you have to select the flash DB. Then you have to select.
I think so. I'm not sure from which link we have to download this tar file. Is it part of the Postgre installation?
Yeah.
Some other different. Some other
no,
thing was given?
Postgres.
So you mean to say when we install the Postgre this thing, so it will become with that thing only, right?
Yeah.
When you download the data set, in that only you will get one PDF file, one SQL file, and one tar file when you download the data set from resource from instructor section.
Okay. You mean to say from the resource from the instructor, so there only we have download, right?
Means in that data set is given. So when you download, click on download, you will get a file. In that there will be FLIS, LIS, and university. So
Okay, let me share the screen.
Yeah, I'll check that
So,
thing. Thank you.
yeah.
You can
So
show it
you can see the Postgres resource unit. My screen is visible, right?
Yes.
Okay, then a resource from instructor. Then click view the resources. Then you can see the dataset. You have to download the dataset folder.
Yeah.
You can download and extract. And there are three database: FLIS, LIS, and university. So you have to, if you are load using the pgadmin, then you have to load that flisdb.tar file. Or if you are using command prompt or PSQL shell, you can load the database flisdb.sql. That's it. That's why you have to load the all three databases: FLIS, LIS, and the university database.
Sir, to open a tar file, which app we can use in our?
No, you have to just extract and you have to load the pgadmin. Just load the dataset.tar file.
Just load in
Yeah, load and pgadmin. So we have already given one PDF, I think, instruction. You can see. Yeah, loading the data from tar files. So using pgadmin, using command prompt, or using PSQL shell. So you can go through this document. I think it is very helpful.
Yeah.
Okay.
Sir, this PostGRE is an engine or it is a client?
It is a database management system. Postgres SQL, open source database management system.
So this is similar to MySQL and the other.
Yeah.
So do all these database engines take the same syntax for queries?
No. Some syntax may be different, right? So it's a small thing. 90% is the same, but some syntax may be different. Like in MySQL, we already talked. We are using limit clause for top 3 rows. So you have write top 3.
So all students should use.
But in PostgreSQL, we are using limit offset, right? So some syntax may be different.
So it's better everybody uses PostGRE for this course.
Yeah, PostgreSQL, better. So we are recommending. That's why we are recommending using PostgreSQL version 10, because we have tested all the assignments and graded assignment using PostgreSQL version 10.
So can you kindly explain about the difference between database engine, SQL client, and SQL query? Thank you.
Database engine. Which part? I did not got.
So database engine, SQL client, and SQL query.
Database engine. I think not in the syllabus, right? Hello.
No, sir, there was an article which was telling about how to install SQL, how to run SQL, and it said that you have to download these 3 things: database engine, SQL client, and SQL query. That's why I was wondering that what are these 3?
Okay, I think not in the.
Be a SQL client.
It is client server database architecture. PGAdmin is.
Okay, so we just need to download this PostGRE and it takes care of everything.
No, just you have to download the PostgreSQL. Like you have to go to the PostgreSQL. Right.
Yeah, Bikram, it is integrated. You need not to worry about it. Everything is. You have to one interface is there, and you can do everything.
Okay.
Do not need to define everything.
Okay. Thank you.
Yeah.
Then you have to go to the Windows. Then download the installer. Then you can just install 10.22. Right, that's it. Okay.
Thank you, sir.
Oh yeah. Okay, so if you have any doubt, we can ask.
Sir,
Otherwise, yeah.
what is this data dictionary? The one
Okay,
question
so
is great assignment, so I'm asking.
okay, data dictionary. See, data dictionary means it contains metadata, right? Hello.
Yeah, I'm hearing.
So, what is it metadata? It's data about data, right? Hello.
Yeah, sir, you are audible.
Okay. So, data dictionary is in general content information about the following, like name of all the database and their schema. Then content table constant such as primary key attributes, foreign key information. Primary key attribute and foreign key information we will learn about with 3. Then content authorization, like which authorization, like uh, like it insert authorization or delete authorization or update authorization. We learn about authorization in detail in week 3, right? Content detail about all the tables in the database, like what are the tables attributes. It's like structure table, what are the table attribute content, and the physical information about the table. So basically, data dictionary content data about the database.
Okay.
That's yeah.
Data dictionary can reside in the logical or the physical abstraction levels.
So yeah, that is reside in the physical level. So that is referred by the database management system only.
Okay.
Yeah.
So one more doubt. So what is this meaning of relational database? That means what is the meaning of this word relational here? So there could be more types of database other than relational, I think. So
Yes.
In what context it is used, like relational word?
Relational word. Okay, let me define. So there is various data models is present in the there is, you can say, graph mesh models or any other. So let me explain. In this DBMS only we discuss about the relational database management system, means relational database models. So why we call this thing as the relational models? Because everything we represent our data in the table format. Table format means row or column format, right?
Yeah. Okay.
Row and column format, and every tables we define some relationship. So as I mentioned previously, there is 3 tables. Suppose the product, customer, and the order ID, right? So in the order tables, we takes the ordered order ID is the order. Suppose there is the order ID and the product ID and the customer ID. So customer ID, we takes the value from the customer tables, right? And the product ID value we taken from the product ID, right? So there is the relationship. So okay, let me.
Yeah, I understood, sir. Thank you. So,
Yeah.
sir, can you name some other types of databases other than relational?
There is one graph-based model that is used by the Facebook. You can see Facebook, Instagram, right?
Okay. I
So
understood, sir.
yeah.
Yeah. Okay. Thank you, sir. Thank you so much.
Thank you. Any other doubt?
If you do not have a doubt, I think we can bind up the session. Thank you, everyone. Thanks.
Thank you, everyone.
Thank you.
Yeah, thanks, everyone. Thank you for joining.
Yeah.
Thank you, sir.
One question.
Yeah.
Can we
Hello.
in this database?
Your voice is broken. Can you repeat your question?
can we access this MDB file, or can we handle this MDB file, .mdb file, which is open in Access, MS Office Access? And can we run the queries here?
MDB file, I'm not got it. Sure. Question.
See, I have some database which is, I can say, has extension MDB.
.md markdown.
.mdb. Now, which is open in Microsoft Access, MS Office Access.
Okay.
So, can we open this here in this? You can say.
Database management system. You want to say Postgres SQL. So.
Postgres.
So for that, I think you have to explore on the net how to, is that possible or not, that MDB file is possible to restore in the Postgres SQL or not. So, and you have to also, if it is present, then you have to check also syntax also. Then if it got restored, then you can analyze, I think.
Okay, I will take it.
Yeah.
I want to add something. So what I know that you have to first export to all the table into SQL dump file, then you can restore the database in Postgres. So we have to MDB file, you have to export all the table into SQL dump file, then you can, I think you can.
Okay, so we have to first dump into some SQL file.
Yeah. Then we can add, you can restore the database.
Okay, I will try. No problem. Thanks.
Okay. You can explore in the web.
Yeah. I will try. Thank you.
Sir, and one more thing, can we arrange these sessions in evening, sir? Because Saturday is also working day for us. So I'm a working professional. So could we arrange these sessions in evening?
I think we have one session. So I think it's Thursday evening session. Yeah, I will discuss with him and let you know it's possible to arrange in evening or not.
So morning is also not very. I mean, it's good to. I mean, we are fresh, and so that's why we can attend more attentively in morning.
Yeah.
Okay, sir. In the calendar, when will we get our next session? I mean, it's not updated.
Yeah, I'll talk with Institute team and let you. I will update.
Okay.
Okay. Thank you, everyone. Thanks for joining.